Welcome to Modern Retrogramming with Plasma. This is Introduction to Plforth, the interactive programming language for the Plasma environment. Let's go ahead and fire up the Plforth module and take a look what words are built in from the get-go. It's a pretty minimal version of Forth, but as we'll see, it's easily expanded. But for Plforth, debugging was of paramount importance. So let's show off with a couple of test words what the debugging facilities inside of Plforth look like. Here's a couple of silly little words, but we'll run them. We'll see they just count, square the number, and print it out. Plforth will allow us to show the compiled words for the other words. So here we can see what square is compiled into and test. Here we see the compiled versions of do and do loop. Very useful for seeing what your words are internally. We can turn on tracing so that we can watch the words being executed along with the stack values. And we can subsequently turn off tracing with trough. Now we can run the program as usual. We also have the ability to interactively turn tracing on and off with Control-T. So we can just toggle the tracing of the program as it runs. Control-C will allow us to break into the running program so we can modify values, examine code, examine state of the running program. We can also turn on single stepping so that we can now run our program one word at a time and view its state as it runs. We just allow it to move along with pressing a key between each word it runs. Here we just step every word, seeing the state, watching the stack values, and giving detailed information on the running program. We can again use Control-C to break back into the program, turn off tracing and single stepping, and continue on. We can also set breakpoints on a word when it gets executed. So here we'll breakpoint when square is called and run it again, and it will break as soon as square is executed. We can continue on. We can keep doing this, looking at the state of the stack and modifying anything we need to, examining other variables. And then we can disable the breakpoints and continue on just like as before. I mentioned earlier that Plforth is a Plasma module actually written in Plasma. So it only required a very minor tweak to the Plasma environment to provide linkage between Plforth and the underlying Plasma symbol table. Here we're running the Plasma script that creates a lot of convenience words to provide Plasma features to the Forth program. Here we're changing the ProDOS prefix and using the catalog module as part of the Plasma environment, now directly accessible inside of Forth. To further show this off, we can use the extensive floating point modules based around the Apple Sane library, the standard Apple numerics environment. This provides very high quality IEEE floating point using 80-bit floating point numbers, and so we can import this directly into Forth from our Plasma modules. We now have very nice interactive floating point features available to us. Here we're just showing how to take a string, push it onto the floating point stack, which gets converted into an extended 80-bit floating point number, There are words to import strings, integers, single precision, and extended precision values directly into the floating point stack. We can take these two numbers, we can print them out and show them as an extended 80-bit number. Not too many fourths, I think, can do that. Here we can create our extended floating point variable, create a couple of them, and they allow us to directly manipulate as extended 80-bit variables. Strings are a little more convenient as humans, but the computer prefers to have them as its native format. Here we can take the string, convert it onto the floating point stack, and then save it back out in its native 80-bit format. We'll just play around this for a second, showing that you really have a very powerful RPN-style programmable calculator. Here we'll bask in the glory of our RPN-style calculator interactively being worked with in Plforth. I think it's pretty clever. Very happy how that turned out. Now, there's a lot of words inside the floating point unit, and it can get very tedious if you have to compile something and it has to search a very, very large vocabulary. So, as we can see here, there's a lot of words. So what I've done in Plforth is hash the vocabulary. So 64 entries and kind of a brain-dead hash function, but it worked pretty well to distribute the dictionary entries. It has to be a reasonably simple function for a Portal 6502 interpreting Plasma bytecode. So let's exit out. Let's go back and restart, cleaning everything up. We'll use our Plasma script to provide linkage for all of our Plasma modules. And in this case, once we finally get loaded up, we're going to use the Plasma editor. There's no Forth editor available here, but we have a very nice Plasma editor that we can run directly. Again, everything's a Plasma module. And here we have Rod's Colors, an early Apple II demo that I've used over the years just to kind of show off graphically a little kaleidoscope program demonstrating performance of different types of compilers and underlying systems. Here we have the Forth version, and we have a linkage to a couple modules for doing some simple low-res graphics to set the color, plot a block, this kind of simple stuff. But we can move around our Forth script quite easily with this editor, edit it, change it, write it back out, catalog our files in our scripts directory. Everything that's really useful when you have a rather sophisticated operating system like ProDOS, with subdirectories and the ability to navigate around the system all within Forth. No need to exit out to Plasma command line and come back in. Here we can change to our scripts directory, our root directory, all within Forth. Now we can source our ROD script. Now what we haven't really talked about much is performance. As we see with Rod's Colors here, it's not blazingly fast. This would be about the same speed you might see inside a BASIC, but it leaves a lot to be desired. The ability to interactively debug comes at a price. The indirect threaded code model that allowed Plforth to provide all this great debugging capability, surprisingly easy to modify to generate inline plasma bytecode. Because Plasma was architected using many concepts from the Forth playbook, there's a one-to-one correspondence between the two. The changes to the compiler to support Plasma bytecode generation were surprisingly few. We can see the difference in performance. However, we do lose all of the debugging capability from the indirect threaded code model. Here's a fun way to compare the three different ways of compiling programs in the Plasma system. Here we'll save a word pointing to our Plasma byte-coded version of Rod's colors. We'll switch back to the indirect threaded code model and load Rod's colors again, but now it's running in the original model. For our final demo, we'll show linkage to the Plasma high-res graphics library. This requires us to use a little stub to reserve memory for the high-res screen because it just so happens to be in the middle of the memory map. So this way we're able to work around that easily and run our test script for bouncing a high-res ball around the screen. We did run it in the Plasma bytecode compiler model, otherwise it would run horribly slow. But as Plasma bytecode, it's quite zippy, certainly faster than you would have gotten in the indirect threaded model. So I hope you like that. Thanks for watching.